G'day frothers, welcome back to the bench. Today we're doing something slightly different and we are looking at batteries, namely the Ryobi High Performance. So one of my first videos was about Shrek here, the green Milwaukee, and I was thinking I'd be able to get a glimpse of how the whole high performance Ryobi thing worked, but it turns out this is just a normal battery. Like when I bought it, the pack said high capacity, I think, and so I was like, oh cool, that must be the right one, but turns out high capacity is just Ryobi speak for 5 amp hour, because I guess in Ryobi land that's a big battery. But anyway, I ended up getting a hold of one of the actual high performance batteries that does have the 2 little extra contacts on the back there. Now, legend has it that those extra contacts allow the tool to draw extra current while working hard with these extra contacts in here. And I was like, well, I mean, yeah, let's see about that. So anyway, I decided to grab one of these fairly expensive little numbers here and take a look. So about the batteries themselves, this is the previous form factor here. It's got more black on it. It's got a bit of rubber. Otherwise, they are pretty much the same size. Slight improvement here is the lights on the new version are a fair bit brighter, and you can also see it from the top, which is a nice little addition. So in terms of weight, 5 amp hour is 774. 762. Okay, so this one is a smidge lighter. Now, in terms of performance, let's check the no load speed. Standard battery in there. $1380 RPM. And the HP battery. $1380 RPM. Sounds exactly the same too. All right, so straight off the bat, I am thinking that these won't really improve the drilling speed, but once a drill is actually under load, maybe it'll help a little bit. So let's go get some testing done. So the first test I did was a standard speed drill test like I usually do. I chose an 18mm bit for that one because that's around 2/3 of the maximum capacity of this drill. So realistically, that's the top of its comfort zone. So anyway, let's take a look. Alrighty, and for the 18mm speed drill, that was pretty much no difference. I averaged up a few of those runs and it turned out pretty much the same. It's about a 1% difference. And yeah, not super surprising. Like this battery is really meant to help the motor draw more current when it's under load. This didn't really challenge it that much. So I decided to try and put it under a bit more load, and I did a torque test. So in the torque test, I used the drill to drive a bunch of these big lag screws into a stump. And that basically will lock up at some point, and theoretically the motor has done as much work as it can to get in there. So this really should be a good way of getting the motor under a lot of load, really starting to try draw extra current out of these extra terminals here. So anyway, let's take a look. And the releasing torque turned out about 12% higher with the 6 amp hour battery. Still very low. This tool is, I don't know, yeah, not the torquiest, but there you go, starting to show a bit of a difference. All right, so what I'm starting to see here is the motor isn't really struggling under normal kind of drilling conditions. It does benefit a bit from the HP battery when it's under load, when it's really got to work. which is not the case when it's just doing normal kind of hammer drilling. You know, the bit more or less spins freely as long as there isn't too much dust in there. So I decided to take it up a notch, and I grabbed one of my blocks of 55 megapascal concrete. So 55 MPa is more than double the toughness of normal concrete, which is around 20 MPa. And drilling into that tough ass concrete, I got one of these. So that's a 20 millimeter Milwaukee bit. That is basically the whole depth of the block of concrete. So I drilled all the way in, and after one full hole, I swapped the batteries, cooled the drill bit down, washed it off, gave the drill a bit of a rest. And this took quite a while, so I'll just show you a representative run out of there. All right, so with the big drill in the 55 MPa concrete, that did actually improve things a bit. You can see overall that the high performance battery did drill a bit faster, about 15% faster, which is not too bad. And then I just kept on doing that until the batteries both ran out. So this is also a runtime test as well. So luckily the holes were big enough that I could just poke the the old tape measure in there and measure up how deep I drilled in each one of them. So with the full 5 amp hour battery and this drill bit taking rests in between, it managed to get 99.5 centimeters of drilling in that 55 MPa concrete. Very respectable. And the high performance battery managed to get 129. So very, very nice there. So 20% bigger capacity, and we had 30% extra work done. So that means the remaining 10% must be due to the actual high performance extra current that this battery is providing to the motor. Now, that is a really nice result. It's exactly what I was hoping for. So that's actually telling you how much better the HP battery is over the standard one. So in conclusion, what kind of improvement did the high performance battery give us? So in a standard drilling scenario, there was like a 1% difference. So bugger all, didn't do anything there. In a maximum torque scenario, it gave us 12%. In a heavy drilling scenario, we got a 15% improvement in speed. We got a 30% improvement in how much work was done. And of that 30, we had 20% runtime improvement and 10% power improvement. So I guess at the end of the day, it turns out like that, yes, this is working. This is doing, what it's supposed to. It's providing a bit of extra current to give that motor more power. But at the end of the day, like, does it matter? Do you need it? Like, nah, not really. It's not, Ryobi is a DIY brand, and you're not going to notice that extra 10%. So I wouldn't go rushing out to get any high performance batteries if you want to improve your rotary hammer game. If you want to improve your rotary hammer game, buy a DeWalt, basically. But, that's just the nature of these things. So just do keep an eye out for that. If you are getting interested in the whole high performance thing, just think about what your tool is actually doing. Is your motor actually struggling? Does your motor need more current? So something like a rotary hammer during your normal use, you're not going to notice because the motor isn't really under any more strain. With this test, it was artificially difficult because I deliberately was drilling downwards, so all the dust would build up in the hole and really bind up and give that a bit of friction. And I also didn't ever just withdraw the bit so the dust got cleared. So, I had to work pretty hard to actually get this difference out of here. Now, if you're using something where the motor is actually under load and the tool is binding up and you're stopping because of that, that's when this kind of battery is going to help. If you're using, a circular saw doing big rip cuts, or you're, using a mower or something like my dad does. He's got one of these dinky little Ryobi mowers. That's the kind of thing where the motor is really bogging down, it's winding down slow, and you actually want to give it more current. With rotary hammers, nah, not really. You know, it's not going to help. So anyway, there you go, guys. It's a bit better, but is it worth it? Are you going to run out and buy them? I wouldn't say so, not unless you're using some other tools. And I guess that about does it. So thanks a lot for watching. Thanks to Shrek for helping out with this test, and thanks of course to everyone who's been subscribing and commenting and everything. Anyway, I'll scratch yous later, and happy hammering.